Okay, so welcome back to our channel. We've been doing this series on linked list, and today I'm going to show you how to add a new node to the end of the linked list. The previous video was on adding the linked list to the beginning of the list. Okay, so we're going to use this coding exercise to learn how to add a node to the end of the linked list each time you insert. Okay, so we're still using the C programming language to achieve this. Okay, so the coding exercise says implement the below function at last. Okay, given one parameter called val. Okay, so that val is the value to be inserted. It says your task is to insert the given integer value val at the end of the linked list. Okay, so normally we have said severally in this series that the first thing to do is to define the struct for the linked list. So we say struct node. Okay, we declare the data part. So we've already said that a linked list has the data part and it has the link part. Okay, and normally we declare the link part with the same name as the node itself. Okay, so pointer next. Okay, with this we have defined what a node looks like. So we've said that a node has a data part and the link part. Okay, so this is how to define it in C programming language. Okay, having defined the node, we then have to create, okay, an empty head node for now, but we're going to make it empty. We're going to assign null to it. Okay, you know every linked list must have a head node. Okay, so we say struct node pointer head, and then we just assign it a null for now, so our linked list is empty. Okay, then after that we'll go to writing the function itself called at last. Okay, sorry, that function returns nothing, so I put void there. At last takes parameter int val. Okay, so now that we're in the function itself, we have to create a new node, okay, that is to be inserted at the end of the list each time. So I say struct node pointer new node. Okay, and then I get its address from calling this malloc function, malloc size of struct node. Okay, now I've gotten an address here from the computer memory and I've assigned it to the new node. Okay, so now our new node has an address. So then I give the data part of this our new node. I assign the value, this value that we're getting through this parameter. I'm going to assign it now to the data part of the new node. So I say new node data part is assigned val. Then I assign the link part of this new node. I assign it null, because you see, each time we're inserting a new node at the end of the list, so it will become the last node, and we know that that last node must point, the link part will be holding a null value. That's how you know that that is the end of the list, because in a linked list, in a single linked list, the last node must be pointing to null. Okay, therefore that link path will actually be holding a null, indicating that it's pointing to nothing. Okay, so I say next is assign null. Okay, so then now I'm going to check if our list is empty. Okay, so I say if the head node is equals to null. Okay, so if our list is empty, now assign the new node that we have created to the head node. Okay, so I just simply say then head is assigned the new node. So now our linked list has only one node. Okay, and that node has become the head node with this line of code, and it's also the last node because it has a value, but the link path is pointing to nothing. Okay, so it's both the head and the last node as it is at the moment. Then I say else, in other words, if there is already something in our list, if our list already contains nodes, I say else. Okay, else what do I want to do? I will then be inserting at the end of that list each time. So I will have to traverse the list, okay, to the very last node before I can then insert another node after that last node. Okay, so I will create a temporary I will create a temporary node, okay, to traverse the list for us. So I say struct node pointer temp. Okay, and I will assign the head node for it because we start traversing from the very beginning of the list. Okay, then I say while the link path I say while temp next, okay, is not equal to null. Okay, so while temp is actually pointing to another node. Okay, so I then traverse the list. I say temp I say each time it should move to another node. Okay, with this line of code. That means if you find something in the list, keep moving. This is what I've written here. Move until you find a node that is pointing to null. Okay, so with this line of code I say keep moving. So it will move, come out and retest here. If it's not pointed to null, it goes back to moving to the next node, comes back to check. Finally, if it is pointing to null, it will leave this block of code and continue its journey where the cursor is now. Okay, so with that then, I know that we've gotten to the last node. So what I want to do now is just point this temporary node, just point the link path to the new node. That's all. Now we don't even need to point this new node link path to any other node because this new node becomes the last node, and here we already declared it to the link path to carry null. Okay, so that's how we know that we're in the last node of the linked list, like we already said. So this line of code is enough for what we want to do. Just point the temporary node link path to the new node that you created. Okay, so let's write a function to print this so that we'll see what we have. So I say print list. Sorry, this function returns value. So I say print list. Takes no parameter. Okay, so same thing with I need to traverse the list each time printing the nodes available, the value of the nodes available. So again, I create another temporary variable, another temporary node called temp, struct node pointer temp. Again, I start from the head. Okay, then I say while temp is not equal to null. This time I'm not saying temp next, I'm saying temp itself because I want to start from the very beginning of the node. Okay. So I'm looking at both, as far as both this one I'm saying as far as both the value part and the link part is not equal to null. Okay. Here I was saying while the link part is not equal to null when we were traversing the list to find the node with the null value in its link part. But here I'm saying while everything, both the data part and the link part is not null. Okay. If you want to test, you can put the link part here and see what will print for you so that you can get the explanation here. But I already know what happens, so I remove that and I say while temp is not equal to null, traverse the list, print each node, and then keep moving. That's what I want to write now. So I say print f So I say print the data part of the new node, of the temp node rather, each time. And then I say move to the next node. So I'll do this. Okay. So with this, we should be okay. Okay, so let me just show you the main line of the code before we compile it. Here, I want to insert a node with the value 10. Of course, since it's our first insert, this will become the head node. Then I want to insert a node with the value 20 to the list, to the end of the list. Okay, so our list will now be carrying 10 as its head node and then 20 as the last node. And then after that, I want to insert a node with the value 30. So our list will be carrying 10 as the head node, 20 as the next node, 30 as the last node. Okay. Then here, I'm just calling the print function that we wrote here. Okay. So let me compile and run and see what happens. Okay, so we have an error somewhere. Let's see. Okay. Oh, sorry. I forgot to put a semicolon here. After defining a struct, you end it with semicolon in C programming language. So we compile again and see. Okay, so all test cases passed. So let's see. Okay, so the expected output is 10, 20, 30. The actual output is 10, 20, 30. So our code is working. Okay, so we created a node with the value 10. Then we assign the one with 20. Then we inserted the one with 20 after 10. And then we inserted 30 after 20. So the code is working. Okay, so like we've said in the past, if you like this kind of content, okay, what you need to do is look down this video. You will see a red button. Click on the subscription button so that you can follow up with next videos as we bring them up. Okay, the series on the link list continues, so if you need to get the alert immediately we drop it, just click on the subscription button. Thank you.